Assalamualaikum warahmatullahi wabarakatuh. My name is Alia Khadijah binti Kamarudin. Today I am from University Kuala Lumpur, Malaysian Institute of Aviation Technology. Today I want to teach you physics and aerodynamics under subtopic optic, light and wave motion and sound. Optic light. We have properties of light emission, color, law of reflection, and refraction, light wave, fiber optic. Nature of light. Light waves are part of a group electromagnetic wave or radiation. Light waves have a certain properties which are common. These are they travel through space at the speed of light 1.600 miles per second and obey the equation V equal to F lambda. They carry energy from one place to another, and on absorption cause a rise in temperature. In free space, all electromagnetic waves have a velocity of light which is c equals to 3 times 10 to the power of 8 mc equal to 1.600 miles per second. Light dispersion. Within the light spectrum, there are 6 colors that can be readily identified, which is red, orange, yellow, green, blue, and violet. Violet, which is indigo. Sir Isaac Newton was the first person to explain this band of color. The separation of white light in this manner into the color of the spectrum is called dispersion. Then, color combination. Objects appear color because their surface will absorb some of the frequency and reflect color. Reflection. Reflection is the change in direction of light wave when it bounces off a boundary. Reflection has two laws, which is the angle of incident is equal the angle of reflection, and the reflected ray lies in the same plane as the incident ray and the normal at the point of incidence. Curved mirror have two types, which is concave and convex. Concave and convex mirror. A concave is a surface that is shifted in toward the middle and away from the observer. While convex surface is a surface where the center is shaped out towards the observer. It is in opposite direction to a concave surface. Point P is known as a pole. N is the center of a curved mirror. Point C is a center of curvature and is the center of the sphere, while point F is called principal focus or focal point. Okay, refraction. Refraction is a change in direction of the light ray occur when light ray move from one medium to another medium. For example, from air to water, this is called refraction. Light refractive index. The equation is m equal to velocity of light in a vacuum over velocity of light in the substance. The refractive index is depend on the wavelength of the light. In a vacuum, light wave travels 300,000 km per second, whereas in gas the velocity falls to 200,000 km per second. Next is Snell's law. Snell's law is equal to angle of incidence equal to angle of refraction. An assumption made in the light follow the same path whether it is traveling in the same sense and direction or in the opposite direction. This is known as the principle of reversibility of light. Lens. There are two basic lens, which is convex lens and concave lens. Convex is converging and concave is diverging lens. The distance between the focal point and the optical center is known as the focal length and is given the symbol F. It is on this value that the calculation of power is made. How an image appears when using a lens can be obtained by drawing two of the following rays. First, a ray parallel to the principal axis which is refracted through the focal point, and a ray through the optical center, assuming no deviation caused by lens thickness. A ray through the focal point which which is refracted parallel to the principal axis, where the image is positioned and its nature can be found by using the formula 1 equal to f 1 over f equal to 1 over u plus 1 over v. Next, wave motion and sound. First is mechanical. Energy can travel in two forms of method. First is particle and second is wave. A wave is a disturbance of a medium which transport energy through the medium without permanently transporting matter. In a wave, particles of the medium are temporarily displaced and then return to their original position. The two most common forms of mechanical wave are transverse wave and longitudinal wave. First, transverse wave. In a transverse wave, particles of the medium are displaced in a direction perpendicular to the direction of energy transport. The particles do not move along with the wave. They simply oscillated up and down their individual equilibrium position as the wave passes. Second is longitudinal wave. Longitudinal wave particles of the medium are displaced in a direction parallel to energy transport. The particles do not move down the tube with the wave. They simply oscillated back and forth about their individual equilibrium position. The wave is seen as the motion of the compressed region, which moves from left to right. Next is water wave. Water wave are examples of waves that involve combination within longitudinal and transverse motion. As the wave travels through the water, the particles travel in clockwise circles. The radius of circle decreases and the depth of water increases. Wave characteristic. We have four characteristics, which is first wavelength, second frequency, third amplitude, and fourth velocity. Wavelength is the distance between two crests. Frequency is the number of wave crests that pass a point every second. Amplitude is the height of the wave crest above the undisturbed position, and velocity is the speed and direction that the wave crest itself is moving. The relationship between wavelength, frequency, and velocity. There is a simple relationship between the wavelength, frequency, and velocity. If you know any two of them can compute using the formula V equal to F lambda. V is the velocity, F is the frequency, and lambda is the wavelength. Interference or superposition occur at point when two or more waves meet. At this point, the combination of waves produce either larger or smaller wave, or even cancel each other out, causing no disturbance at all. There are two common types of interference. First is constructive and second is destructive. Standing wave. Standing or stationary wave occur in wires that are tightly stretched between 2 points. If these wires are plugged or caused to vibrate, transverse waves travel to the end and are reflected back. Waves which are in phase, the combined amplitude is large, and when out of phase is subsequently small or even zero. Standing wave patterns are characterized by certain fixed points along the medium which undergo no displacement. These points of no displacement are called nodes. Meanwhile, midway between every consecutive nodal point are points which undergo maximum displacement. These points are called antinodes. Sound. Sound is an energy and is produced when an object vibrates, causing the surrounding air particles to vibrate also. Sound travels through air or other medium in the form of longitudinal waves. Sound waves are also called acoustic waves, regions of high pressure and low pressure, known respectively as compression and refraction. Doppler effect. Doppler effect is the change in frequency which occur when the source that is emitting the sound wave is moving. Sound wave in front of the object, they become closer together, giving the appearance of a smaller wavelength and of the greater frequency. Wave behind the object, the opposite occurs, giving the appearance of large wavelength and a lower frequency. A Doppler radar is a specialized radar that makes of the Doppler effect to produce velocity data. Sound intensity determined by amplitude of the sound wave. The higher the amplitude, the higher the sound, and it is measured by decibel. Frequency is the number of vibrations complete per second. Frequency equal to 1 over time, which is time in second. Unit is hertz. Sound propagation, transmission and reception of sound. First source, second medium, and third detector. Doppler effect. The Doppler effect is an apparent rise in the pitch or frequency of a sound, and its source approach the hearer, and the decrease in pitch as the source moves away. Sound vibration. Cause waves radiate out from their source at the speed of sound. Aircraft move less than speed of sound. The sound moves ahead of the aircraft. Aircraft flies at the speed of sound produce shock waves. And speed of sound, with which the mechanical vibration of sound travels in an elastic medium. Speed of sound also varies with temperature and altitude. Image number. The ratio of the speed of the airplane to the speed of sound in the same atmospheric condition. Image number equal to speed of the aircraft over speed of sound. K9 is resonance. Resonance is the natural frequency of a given object vibrate naturally or without the external force. Wave. A wave is generally a disturbance that moves through a medium. In periodic wave, parts of the same time follow on another in regular succession. Okay, wave property. Frequency is f equal to 1 over time with its unit hertz. Sound waves are longitudinal waves that consist of varying pressure. They can travel through solid, liquid, and gas. The change in pressure causes our eardrum to vibrate with the same frequency. This produces the sensation of sound. When sound waves spread out uniformly in space, their intensity decreases inversely. Sound. The scale used of loudness or sound intensity level is decibel. Sound travels at different speeds in different materials. Air is the poor conductor, water is the better, and solid is the best depend on the molecule arrangement. More dense the solid material, the best conductor. In air, only speed of sound varies directly with temperature, not pressure, because the change in temperature of atmosphere. When airplane moves through the air, it creates sound waves which radiate in all directions from the surface. When there is relative motion between a source of waves and an observer, the apparent frequency of the wave is different from their frequency at the source. In the case of sound wave, the frequency f is given by f equal to fs in the bracket v plus vl over v minus vs. vl is the sound velocity of the listener. Vs is sound velocity of the source. Vibration. The frequency of vibration depends on the several factors. First is tension, second is length, and third is the mass per meter. Different frequencies sound different to the ear. High frequency are high notes to you, but it is high pitch to the musician. Okay, thank you. That's all from me. Okay, bye. What